This is the first video that starts to guide you towards the mathematical computations that you're going to make with your data. So this first video is talking about confidence intervals, but this is only going to be geared towards anyone who was looking at a percent as your parameter of interest in your study. So if you were averaging numbers to find means, this is not the video that you need to watch. You need to watch the video for confidence interval for means. This is also geared towards you just testing your percentage against a percentage that has already been established. Now we won't cover a lot of that in this video. We'll talk about some of that in the next video. But if you just had one sample and you were finding a percentage from that sample, then this is the video that you need to be watching. So the first thing that you need to be able to compute is called a confidence interval, and what that's going to be is an estimate of where the true proportion lies in the population. So for example, if Tanya wanted to estimate what proportion of her school's seniors plan to attend the prom, and she interviews a simple random sample of 50 of the total of 750 seniors in her school, she finds from her study that 36 of them plan to go to the prom. So what we're interested in is we are interested in the population, which is all of the seniors at the school. And our parameter of interest is P. We want to know the percent of those seniors that are planning to attend the prom. Now, it is probably not feasible for us to go talk to all 750 seniors to make that calculation. So she took this sample of 50 so that she can try to get an estimate of what that true percentage is. So with anything dealing with proportions, there are a couple of conditions that have to check out in order for this to work. The first condition is we have to have a randomness in our study. In this case, she did select a simple random sample from her school, so that condition checks out. You also have a condition called the success failure condition that needs to be checked out. Success failure says that n times p hat has to be greater than or equal to 10, as well as n times q hat has to be greater than or equal to 10, where n is the number in my sample and p is the proportion of students that said, yes, I'm going to prom. This is the number of successes I had in my experiment. Now, you could find this proportion. You're going to need it. You're going to kind of need to know it anyway, but you could find the p hat by taking the number that said they're going to prom, which is 36, out of the total number in the sample, which is 50. And if you just do that division, you're going to end up with 72%. So p hat is equal to 0.72. The q hat is going to be the percent of failures. So if I know 36 out of 50 are going to the prom, if I just subtract that 36 from 50, that's going to leave me with 14 people out of 50 that are not going to the prom. Or we could just take 0.72 and subtract it from 1 to get the other part of this percentage. You could look at it either way. So this should give me a 0.28, 28% of those seniors that are not going to the prom. Now, you could take each one of these parts. The number in my sample was 50, and you could multiply it by the p-hat, which is 0.72, and I'm going to write that down just because for some problems you will need to do that. However, if you type in 50 times 0.72, you're just going to get 36 because NP represents the number of successes or the number of students that are going to prom, and they've already told us that in the problem. Okay, so in Q, I don't need to type in the number in my sample and the percentage that are going. I already know the number of failures in this, and we said that was 14. Now 36 is greater than or equal to 10. 14 is also greater than or equal to 10. So that second condition for success failure also checks out. And then the third condition you need to check is called the 10% condition. And that's where you just need to say, okay, my sample size is 50. And if I multiply 50 by 10, I get 500. And this needs to be, this represents what your population has to be at least. Okay, so I have at least 500 seniors in this school. And I know that because they've already told me I have 750. So that is your third check. Now, you don't necessarily have to talk about all three of these conditions when you do your presentation. You do have to check it to make sure that you can run this mathematical data and that it will be accurate. You can just make a general statement in your presentation that you did check the conditions and they were all met, but you don't have to specifically talk about each one in your presentation. Now, because these conditions are met, there are a couple of things I can do with this. The only thing that this video is going to talk about is the confidence interval, and your calculator will do this confidence interval for you. So let's say I want to construct a 90% confidence interval for P, and I'm going to show my method. So your calculator, and that's the method we're going to use, does what's called a one proportion Z interval. I'm choosing one proportion because I only had one sample, and we were looking at P, the percent of students that were going to the prom. So that's why I'm choosing one proportion. And I'm choosing Z interval because I want the confidence interval. When you go to your calculator, you're going to go to math over here on the left. You're going to use the right arrow to, I'm sorry, that's not right. Go to stat and then use the right arrow to highlight test. And you're going to scroll all the way down to letter A. Letter A is the one proportion Z interval. And when you choose enter, it's going to ask you for some information. X is the number of successes that you had in your experiment. It's basically asking you for that P hat on these first couple of steps. So I had 36 seniors that told me that they wanted to go to prom. And then N is the number that was in my sample. So 36 out of 50 told me they were going to prom. Then it asks you for your confidence level. For this particular problem, my confidence level is 90%. So I am going to change this confidence level here and type in 0.9 instead. And then once you have that all typed in, you're just going to hit enter on calculate, and it's going to spit the confidence interval out for you. It will again tell you what your P hat was for this sample, as well as your sample size, but the parentheses are what's giving you your confidence interval. So this goes from 0.61556 up to 0.82444, and that is your confidence interval. And what that tells me about this, and this is the most important piece to this, not only should you be able to calculate a confidence interval, you should also be able to interpret that interval in context of the problem. So here's kind of a sentence frame that you can use. We are 90% confident. First, state what confidence level you did this at. That the interval from, and then just copy the interval you got, 0.61556 up to 0.82444, captures the true, and then you're going to state whatever your population parameter was. So we were looking for the true percent of seniors that attended the prom. So this captures the true proportion of seniors attending the prom. Okay, so this sentence frame will work for any confidence interval you can compute. This will change depending on what confidence level you did your study with. Obviously, this will change depending on what confidence interval you got for your study. And then this piece right here will change depending on the context of your problem and what parameter of interest you were looking for. Okay, and that's all there is to confidence intervals. Now, also associated with this video, you should also watch hypothesis testing or significance testing for a proportion, because you will also need to do that piece as well.